Hello and welcome. Let's continue where we left off in our previous demo. So let's get started. Now the next step is to install kubectl. Kubectl is a command line utility that helps us interact with our Kubernetes cluster. In our previous demo where we used Cloud Shell to access Kubernetes cluster, the kubectl utility comes pre-shipped with the Cloud Shell machine. In this case, the kubectl is not installed on my local machine. We can confirm that by running the kubectl command. It says kubectl command not found. Let's go ahead and first install kubectl packages. I'm referring this documentation over here to install and set up kubectl. In my case, it's a Linux terminal, so I'll select Linux and let's copy the curl command to download the latest release. Let me head back to my local terminal and paste the curl command. Let's hit enter. All right, so the package has been downloaded. Let me do an ls. Confirm if the kubectl package has been downloaded. Next thing is to make the kubectl binary executable. Let's run the chmod command. Let's hit enter. And finally, we must move the binary into your path variable, which is OCIR local bin kubectl. Let me copy this command. Paste it here. All right, so our kubectl has been installed and configured. Let me run a kubectl command again. And as you can see, it gives me all the options, which means kubectl has been configured correctly. Let me clear the screen. Just to check the kubectl version installed on my local terminal, let me run the kubectl version command. And the version that it's running is 1.28.4. Let me clear the screen. All right, so now that we have configured OCI CLI, installed kubectl, and also copied the public API signing key pair to our OCI console, the next thing that I'll be doing is now setting up the kubeconfig file. So let's go back to our OCI console. Let me go to the Kubernetes cluster page. Let's click on developer service. Let's go to Kubernetes cluster. Let's click on the cluster from the cluster list page. Let me click on access cluster this time. And this time around, we'll be using the local access. So let me click on local access. And let's follow all the steps given here. By far, we have already downloaded and installed OCI CLI. We have configured it for use. And as the information says that the OCI CLI version must be 2.24.0 or later. And in our case, it's the later version. The next thing that we'll be doing is to create a directory to contain the kubeconfig file. Let me copy this command and let's head back to our local terminal. Let me paste that command over here. This creates a hidden kube directory in my home directory. Let's hit enter. Let me go to the home directory and let's do an ls. And as you can notice, we have this .kube directory created. Now the next command that I'll run is to access the kubeconfig file for our cluster via the VCN native public endpoint. Remember, our cluster's Kubernetes API endpoint is in a public subnet for which I'll be copying this command. Let's head back to our local terminal and paste the command here. Let's hit enter. And it says a new config has been returned to the kubeconfig file, which is available in the .kube directory that we just created. So let me go to the kube directory. Let me hit enter. And if I do an ls here, you can see that the config file is created. Let me open up the config file for you. As you can notice, it has all the information like the cluster OSID. The cluster OSID ends with DPQ. Let me head back to our OCI console. Let me close this. And just to confirm, our cluster OSID is ending with the letters DPQ. This is the cluster that we have created access to from our local terminal. Now that we have set up the access, the last step is to verify that the kubectl can access the cluster, for which I'll be running the kubectl get nodes command. Let me hit enter. And there you go. From the output, we can see that it has returned us the list of worker nodes. And this confirms that we were successful in setting up local access to our cluster Kubernetes API endpoint in the public subnet. Now let me run a command with inline configuration to create a deployment within the Kubernetes cluster. The command is kubectl create deployment. Let's give the deployment a name. This is Mahindra-Nginx. Let's provide the container image. Let's set the replicas for the pod to 2. Let's hit enter. And it says the deployment is created. Let's check whether the pods are in action. So let's do a kubectl get pods command. And there you go. We can confirm that the 2 pods as part of our deployments are in the running state and have been created successfully. Well, that's it from this demo where we saw how to set up local access to our cluster. I hope you enjoyed the demo. See you in the next one. Thank you so much for watching. Hello and welcome to this lesson on connecting to managed nodes using SSH. I am Mahindra Mehra and I am your senior OCI instructor at Oracle University. So let's get started. Throughout the life cycle of your Kubernetes cluster, you may need to access a cluster worker node. This access could be for maintenance, configuration inspection, log collection, or other troubleshooting operations. Moreover, it would be nice if you could enable this access whenever it's needed and disable when you finish your task. While it's possible to configure Kubernetes nodes with SSH access via Cloud Shell or your local terminal, this also makes worker nodes more vulnerable. Using SSH requires a network connection between the engineer's machine and the compute instance, something you may want to avoid. Let's unravel the process of connecting to managed nodes using SSH. Here's your step-by-step guide. Firstly, if you provided a public SSH key during the creation of a managed node pool, that key is now securely installed on all worker nodes within the pool. Now, if you're on Unix or Unix-like platforms including Solaris and Linux, SSH is your gateway to administrative tasks on these worker nodes. It's worth noting that virtual nodes, however, are off limits for SSH connections. The method to connect depends on whether you opted for public or private subnets for your worker nodes. For those in public subnet, a crucial step precedes the connection, defining an ingress rule in the network security group or subnet security list. Accessing the managed nodes in public subnet through SSH requires an ingress rule allowing SSH access to port 22. The rule scope spans from source 0.0.0.0/0, welcoming connections from any source port. Need the public IP for your SSH connection? There are two options. Either utilize the kubectl get nodes command to fetch the access IP, or head to the cluster console, navigate to the node pool tab, click on the pool name, then hit the nodes tab to unveil the public IP of your worker nodes. Let's understand how to SSH to manage nodes in public subnet from Unix machine. Enter the kubectl get nodes to see the public IP address of worker nodes in the node pool in a cluster. And then enter SSH opc@node IP address to connect to the worker node, where node_IP_address is the IP address of the worker node that you made a note of in the kubectl get nodes command. For a smooth SSH experience, if your private key isn't in the default location, ideally in the .ssh directory under your home directory, no problem, you've got options. Use the -i option to specify your keys, file name, and location. It's like giving directions to your SSH utility, ensuring it finds your key precisely where you want it. So whether it's a unique directory or under a distinct name, -i is your go-to for a seamless connection. For our second option, we can seamlessly integrate the private key file name and the location into an SSH configuration file. The two potential homes for the information are the client configuration file, typically found at .ssh directory in your home directory with the name config, or the broader system-wide configuration file at etc/ssh_config file. This method offers a centralized and tidy approach, streamlining your SSH connections. How do you provide private key file name and location into these config file? Is basically by using the identity file keyword and the path to your private key file. In ensuring a secure SSH setup, remember that permissions on your private key file play a crucial role. You must have read, write, and execute access. But it is equally important to prevent other users from accessing the file. To set the right permission, you can use a command like chmod 600 and include the path to your private key. This ensures that only the owner of the file has the necessary permission, keeping it confidential. It is worth noting that if permissions are not set correctly and the private key becomes accessible to other users, the SSH utility will simply ignore the private key file. Let's explore SSH access to managed worker nodes residing in private subnets. Here's what you need to know. Firstly, worker nodes in private subnets exclusively support private IP addresses and don't come with public IP addresses. Their accessibility is confined to resources within the VCN. To gain SSH access to these private dwelling nodes, one option is to leverage Cloud Shell Private Access. This offers a secure path for SSH connections without exposing the nodes to the public internet. Oracle recommends the use of Oracle Cloud Infrastructure Bastion service for enabling external SSH access to worker nodes in private subnets. Stay tuned as we dive deeper into this recommendation in the subsequent lessons of this course. In conclusion, we've covered the essential need to access worker nodes, tailoring our approach based on their positioning in either public or private subnets. I hope you found this lesson insightful. See you in the next video and thank you for watching. Hello and welcome to this demo on connecting to managed nodes in public subnets using SSH. Let's get started. Before we dive into connecting to managed nodes in public subnets using SSH, let's quickly recollect from our previous demo where we created an OKE cluster. So let me take you to the cluster service. Let's click on Kubernetes cluster from the recently visited service. We created a cluster with the name OKE-public-demo-1 in our CTD OKE compartment. And during that process, I provided a public SSH key when creating a managed node pool in the cluster. And this public key is then installed on all the worker nodes in the node pool. If you remember, we have one node pool with 3 worker nodes in that pool. Now that we are clear that we have a node pool with worker nodes having public SSH keys installed in them, on Unix and Unix-like platforms including Solaris and Linux, we can connect through SSH to these worker nodes using the SSH utility. Basically an SSH client to perform various administrative tasks. However, it is important to note that connecting to virtual nodes using SSH is not possible for this setup. And for this demonstration, I'll be using the Cloud Shell machine. So let me spin up the Cloud Shell machine. For your information, Cloud Shell comes pre-installed with SSH utility, which we will be using throughout our demo. Let me quickly show you. So I'll do an SSH space -v command. And this confirms that the SSH is installed. Let me also show you the SSH key which we generated in our previous demo and the public key that we installed on our worker nodes. Let me take you to our default SSH directory. And if I do an ls over here, and this is the public key which was copied to all our worker nodes in the node pool. Also note that the permission on the private key file must allow you read access but prevent other users from accessing the file, which means other users should not have any sort of permissions on this file. Let me quickly check the permission on the file. Basically, I must have read access on the file. Let me run ls-al command and supply the private key file name, which is id_rsa. So from the output, it's clear that I have the read access on my file, whereas the other users don't have any sort of permissions on this file. Letting you know, because if the permissions are not set correctly and the private key file is accessible to other users, the SSH utility will simply ignore the private key file, and which may result into errors while SSHing into the worker nodes. Let me clear the screen. For now, I'll minimize the Cloud Shell terminal. Now, before we proceed, it's crucial to set up the necessary security configuration that will help us connect to a managed node in a public subnet using SSH, for which we must define an ingress rule in the applicable network security group or subnet security list to allow SSH access. Let's quickly check the security list for our worker nodes and see if this rule exists, for which I'll click on the cluster. And from the network information, let's go to the VCN. Now, since our worker nodes are part of the node subnet, let me click on the node subnet over here. And this is the security list which is in place. Let me click on the security list. And we need to check for the ingress rule that allows SSH traffic from the outside world into our worker nodes. And as you can see, this security rule is available by default in the security list. Ideally, with clusters created using quick create option, this rule is auto-generated. However, for custom created clusters, one must ensure it's manually added. Now that we see that the rule is available, our next step is to find out the IP address of the worker node we want to connect to. Now let's head back to our previous tab and let me restore the Cloud Shell terminal. Let me clear the screen. Like I said, we need to find out IP address of the worker node we want to connect to, and there are several ways to do this. One of it is to use the kubectl get nodes command. So let me run the kubectl get nodes command with the flag -o wide. The command is kubectl get nodes -o space wide. As you can observe from the output, we get to see the external IPs associated to our worker nodes. Right, so these are all our worker nodes. So we get to see their private IP as well as the external IPs. External IPs because they are part of the public subnet. Another way using which you can get this information is using the console. In the console, let's go to the cluster detail, and in the cluster details, let's click on node pools. In the node pool, click on the pool name. And these are the list of worker nodes, right? And you get to see only the private IP over here. So when we click on any of these worker nodes, let's say I click on the first worker node. This will open up the worker node information page in the compute service. Right, so as you can see, we are in the compute instances page where we get to see the instance detail for our worker node. And this is the public IPv4 address for one of our worker nodes. And we'll be using this IP to connect to that worker node. Right, so let me copy this IP address and let's head back to our previous tab. Let me clear the screen over here. Let me maximize the Cloud Shell terminal. Now the command to connect to the worker node is SSH space the username, which by default is OPC, at the rate the IP address of the worker node to which we want to connect. So the IP address I just copied. Let me paste it here. Well, just for your information, I have not specified the path to our private key because the private key is in the default location where SSH utility expects it to be, that is in the .ssh directory in your home directory. In case you have your private key installed elsewhere, you need to provide the complete path to your private key using the -i flag. Since my private key is in the default directory, let me go ahead and hit enter. As you can see, I have managed to make an SSH connection to my worker node. From the prompt, you can read that it is OPC at the rate the worker node instance name. Let me confirm the worker node name. As you can notice, this one ends with BHQ-0. And from the instance detail, we can notice that this is also BHQ-0. So they both are matching. Now to come out of your SSH session, you need to just type exit, and this will close the SSH connection with your worker node. Similarly, if you want to SSH into other worker nodes, you just need to find their IP address, public IP address. And like I mentioned, you can use kubectl get nodes-o wide command, or you can simply go to the instances page. And from here, you can simply identify the worker nodes that are running as part of your cluster and simply copy the public IP address from the list and just use it to SSH into those worker nodes. Let me demo it to you by SSHing into one of the other worker nodes. The command is SSH OPC at the rate, and let me paste the IP address. So this time we are SSHing into another worker node whose IP address is 129.146.32.58. Let me go ahead and hit enter. Well, simply type yes on the prompt and proceed. That's it. So from the prompt, we can see that we have the shell access of another worker node that is connected to our Kubernetes cluster. With this, we come to the end of this demo. I hope you found this demo useful. See you in the next one. Thank you so much for watching. Hello and welcome to this lesson on setting up a bastion for cluster access. I am Mahendra Mehra and I am a senior OCI instructor at Oracle University. So let's get started. Let's start by addressing the fundamental need. When utilizing kubectl for cluster operations or performing administrative tasks on worker nodes, accessing the Kubernetes API endpoint is non-negotiable. However, security list rules or the placement of the API endpoint and worker nodes in private subnets might pose restrictions. In such scenarios, the solution lies in setting up Bastion through the Oracle Cloud Infrastructure Bastion service. These Bastion acts as secure gateways, granting controlled access to Kubernetes API endpoint and worker nodes. Let's delve into an overview of the OCI Bastion service. This service is designed to provide a secure, controlled, and audited gateway to resources within your virtual cloud network. How does it work? OCI Bastion deploys Bastion hosts directly within your VCN. These hosts act as intermediaries, facilitating SSH connection to target resources such as compute instances, container engine for Kubernetes clusters, or databases. One notable feature is the support for private endpoints, ensuring secure access to resources tucked away in private subnets. Furthermore, granular access controls are a key strength of the Bastion service. It enforces stringent controls, ensuring that only authorized users can access resources via the Bastion hosts. This level of security and control makes the OCI Bastion service a robust solution for managing access to your cloud resources. Setting up Bastion and Bastion sessions involves a series of tasks, and depending on your organization's structure, these responsibilities may be distributed as follows. The VCN administrator is responsible for creating the VCN, subnets, and security rules for both the Kubernetes cluster and the bastion. The cluster administrator takes charge of creating bastions, managing access to both the Kubernetes API endpoints and worker nodes. They also handle the creation of bastion sessions for worker node access. Lastly, the cluster user is involved in creating bastion sessions to access cluster API endpoints. Remember, IAM policies are crucial in enabling these individuals to manage their respective operations on the cluster effectively. This diagram shows an example cluster configuration with Bastion providing secure access to cluster Kubernetes API endpoint and worker nodes, both of which are situated in a private subnet. When creating the Bastion, the target VCN and the target subnet should correspond to the VCN and the subnet where the OKE cluster resides. And of course, you must set up the route table rules as well as the security list rules, which includes the ingress and egress rules to allow communication to and from these resources. Let's explore the essential IAM policies required for Bastion operations. Users need specific permissions for various Oracle Cloud Infrastructure resources when creating a Bastion or session. Here are some examples. For user group like security admins responsible for overall Bastion management, which includes tasks such as create, update, and delete all Bastion resources in the entire tenancy, we must set up these policies to allow them these operations, which includes to manage Bastion family, manage virtual network family, read instance family, read instance agent plugins, and to inspect work requests in tenancy. For Bastion users responsible for session activities such as create, connect to, and terminate sessions in the entire tenancy, we must set up the following policies. It includes use bastions in tenancy, read instances, read VCN, manage bastion session, read subnets, read instance agent plugins, read VNIC attachments, and read VNICs in tenancy. If you wish to write more fine-grained policies for user groups like sales admin with specific target host access, you can use the following policy, which is highlighted in bold. Here, the session underscore username is the specific operating system username when creating a session on the compute instance. For user groups like security auditors with view-only access, policies to read Bastion family in tenancy will ensure a finely tuned control over Bastion's operations. For cluster users to connect to the private Kubernetes API endpoint of a cluster, there are specific tasks that the VCN administrators, cluster administrators, and cluster users need to perform collaboratively. As the VCN administrator, here are the steps to set up egress and ingress security rules, enabling a Bastion to access the Kubernetes API endpoint. Firstly, create a new private subnet to host the Bastion within the same VCN as the cluster you want to provide access to. Note that if a subnet for accessing worker node has already been created, you can reuse it. Add a TCP/6443 egress security rule to the security list associated with the Bastion subnet. This rule allows traffic from the Bastion subnet to the Kubernetes API endpoint subnet of the cluster. If not already present, add a TCP/6443 ingress security rule to a new or existing security list associated with the subnet hosting the Kubernetes API endpoint. This rule allows traffic from the Bastion subnet into the Kubernetes API endpoint subnet. These steps will ensure secure communication between the Bastion and the Kubernetes API endpoint. As the cluster administrator, the following steps guide you in setting up a bastion to access the Kubernetes API endpoint. Firstly, create a bastion using OCI console and set properties, such as define the CIDR block allow list to specify authorized address ranges, such as 0.0.0.0/0 for internet access or a more restricted range. Once created, access detailed information about the bastion, including its OSID, and provide cluster users with the bastion OSID for connection. Ensure that the necessary IAM policies are in place to authorize cluster users for bastion use. As a cluster administrator, setting up IAM policies is crucial to control and limit the resources accessible to cluster users via bastion. For instance, you might want to restrict users to only access a cluster's Kubernetes API endpoint, excluding SSH access to worker nodes. The following example policy allows users in the group cluster user to create, connect to, and terminate bastion sessions for Kubernetes API endpoints in subnet 10.0.0.11/32 on port 6443 in compartment ABC. This example assumes the bastion is already created and the networks and the worker nodes are in the same compartment as the bastion. Always ensure network access is configured to the minimum required for enhanced security. As a cluster user, here's a step-by-step guide to create a bastion session for accessing the Kubernetes API endpoint. If not done already, create the kubeconfig file for the desired cluster using OCI CLI. Edit the cluster's kubeconfig file to specify the IP address and port for listening to SSH traffic. You can do so by locating the line server : and the HTTPS URL. Specify the IP address and the port, which is 6443. Next step is to create bastion session using either the console or the CLI. Next step is to obtain the SSH tunnel command either through the console or the CLI, which includes the necessary details like private key, local port, session IP, and port. Finally, execute the SSH tunnel command on your local workstation or in Cloud Shell, ensuring proper edits for private key path, local port, and background execution. Now, you can perform kubectl operations on the cluster until the SSH tunnel or bastion session times out. As this video is getting a bit lengthy, I'll pause here and we'll continue with the steps to access the managed nodes using SSH in the next video. So stay tuned for more insights and information. See you in the next video. Welcome back. If you missed the previous video, be sure to check it out for essential context. Now let's pick up from where we left off. So let's get started. Now let's take a look at steps to have SSH access to managed nodes. For cluster users to gain SSH access to managed nodes through Bastion, vCN administrators need to follow these crucial steps. They need to create a new subnet to accommodate the Bastion within the same vCN as the targeted cluster. Make a note if a subnet already exists for a Bastion accessing the Kubernetes API endpoint, it can be reused. Next step is to add a TCP/22 egress security rule to the Bastion subnet's associated security list. This rule permits traffic from the Bastion subnet to the worker node subnet, ensuring SSH communication. If not already present, include a TCP/22 ingress security rule to a new or existing security list which is linked to the subnet housing the worker nodes. This rule enables traffic from the Bastion subnet to the worker nodes. specifically facilitating SSH communication. By implementing these VCN administrator steps, you can ensure that the bastion acts as a secure intermediary for SSH access to the managed nodes. As a cluster administrator, here are the essential steps to configure a bastion for SSH access to managed nodes. Firstly, enable the bastion agent or the targeted worker node using console. Allow up to 10 minutes for the change to take effect and ensure the bastion plugin status shows as running before proceeding. Secondly, create bastion and configure properties such as bastion name, target VCN, subnet, and CIDR block allow list. Share the OCID of the created bastion with cluster users and ensure that appropriate IAM policies are in place to authorize the cluster users to utilize the bastion. If desired, set up IAM policies to restrict cluster users' access to resources within the bastion. And as a cluster user, these steps guide you through creating a bastion session to facilitate SSH access to managed nodes. Firstly, create bastion session. Utilize the console or CLI to create bastion session. You can refer to official documentation for detailed instruction. We will be covering the same in a demo. Secondly, obtain SSH tunnel command. Using either the console or CLI, retrieve the command to create an SSH tunnel. This command will establish the necessary connection for SSH access. Once you have the command, you can execute the obtained SSH tunnel command on local workstation or within Cloud Shell. This ensures seamless access to managed nodes. Make a note, if needed, modify the SSH tunnel command by replacing the private key with the path to the file containing the private key of the SSH key pair used for this session. By following these steps, you are ready to perform seamless operation on the managed nodes until the SSH tunnel or the bastion session reaches its timeout. As we wrap up, we've navigated the intricacies of setting up bastion for secure Kubernetes cluster access. From VCN administrators to cluster users, each role contributes to a controlled and secure environment. Remember the key steps, IAM policies, and the empowerment each role holds in this process. Stay tuned for more insights in our upcoming lessons. Thank you for watching and see you in the next video. Hello and welcome to this demo on setting up a bastion to access the Kubernetes API endpoint. Here's an overview of our setup: a Kubernetes cluster with its API endpoint in private subnet, along with worker nodes in private subnet and load balancers in public subnet. We'll be creating a bastion host and place it in the same VCN as the cluster we want to provide access to. And we will have option to either create a new private subnet for the bastion host or utilize an existing one. We will be using the latter option. Concerning policies, I will be conducting this demo with administrative privileges. I have default access to all the resources within the tenancy. However, if you run this demo as a limited user, you must ensure specific permissions for creating sessions and bastions, and we have covered this in our previous lesson. As we covered in the lesson, the process of setting up a bastion to access the private Kubernetes API endpoint can be divided among various users such as VCN administrators, cluster administrators, and cluster users. However, for the purpose of this demo, I'll be consolidating all these tasks into a single user operation. So let's get started. I have logged in into my OCI console. First up, let's start by creating a Kubernetes cluster with its API endpoint and worker nodes in private subnets. Let me access the Kubernetes cluster service. Ensure that you are in the right compartment. In my case, it is CTD OKE. Let me click on create cluster. I'll be using the quick create workflow. Let's click on submit. Let me give my cluster a suitable name. Well, my cluster name is OKE private bastion demo. Compartment is ctdoc. Kubernetes version is 1.27.2, which I'm okay with. And now under the Kubernetes API endpoint, let me select private endpoint. Under the node type, let me select manage nodes. Like I mentioned earlier, we'll be placing our worker nodes in the private subnet. So let's choose private workers. Let the shape and image be the default values. Let the node count be 3. Let's click on show advanced options. And here let's specify the SSH key to access our worker nodes. Let me click on paste a public key and provide an existing public key that I have already created. This is my local terminal where I've already created a SSH key pair. Let me show you using ls command, and these are my private and public key. Let me open up the public key. Let me copy the content. Let me clear the screen. Let's head back to our console. And I'll be pasting the public key over here. Let's scroll down. Let the label be the default label. And let's click on next. On the cluster review page, we can review the cluster information. Everything seems okay to me. Let me click on create cluster. And this time I'll be creating a cluster of type enhanced. Let me click on create cluster button. Let's wait until the cluster and the associated network resources get created. This will take some time. Let's wait until the cluster status is active. Well, after a few minutes, my cluster status is now active. Now, as you know that the clusters, Kubernetes API endpoint and worker nodes are in private subnet, we know that we won't be able to access our cluster from a different network. Let me quickly show it to you. Let me click on access cluster. And since our API endpoint and the worker nodes are in private subnet, we cannot access it via Cloud Shell. The only access that is available is local access. And I already have downloaded OCI CLI and configured it on my local machine, as well as I've configured the kubectl command line utility. Let me copy this command to set up kubeconfig file on my local machine. Let's head back to our local machine. Let me switch to the home directory. Let me paste the command here. Let's hit enter. And it says the kubeconfig file has been written. Now let's try to run kubectl command and see if we can access our cluster. Well, no surprises here. We were not able to connect to the cluster and it says no route to the host. Since we're trying to access the cluster from a different network and that is not possible. Now, in order to access the cluster, we'll have to set up Bastion host and set up Bastion sessions to access the cluster. The first steps that we must perform is to establish a new private subnet within the same VCN as our target cluster for hosting the Bastion. But remember, like I mentioned earlier, you can create a new private subnet to host your Bastion, or you can leverage an existing subnet from within the VCN. We will be going for the latter option. Next thing is we must ensure that we add an egress rule allowing traffic from Bastion subnet to clusters Kubernetes API endpoint subnet on port 6443. And we must set up an ingress rule to allow traffic on port 6443 on our Kubernetes API endpoint subnet. Let's get back to our console. Let me close this page. Like I mentioned, we'll be leveraging the same private subnet to host our Bastion where our Kubernetes endpoints are hosted. Let me go to the VCN. You can go to the VCN by clicking on this link over here in the cluster information page. Out of the 3 subnets that are present in this VCN, one is for the worker node, which is a private regional subnet. The other one is a load balancer subnet, which is a public regional subnet. And third one is our Kubernetes API endpoint hosted in a private regional subnet. Let's copy the subnet CIDR block, which will be required while we create the ingress and egress rules. Let me select the Kubernetes API endpoint subnet. Let's click on the security list. for that subnet. And let's start by adding the egress rule first. And let me click on add egress rule. Let's provide the destination CIDR that we just copied. And let's provide the destination port range, which is 6443. Let's give it a description. It says allow Bastion to Kubernetes API endpoint communication. Remember, we are hosting Bastion and Kubernetes API endpoint in the same subnet, which is 10.0.0.0/28. Click on add egress rules. Let's go to ingress rules now and click on add ingress rule. Here we need to provide a rule that allows traffic into Kubernetes API endpoint subnet from the Bastion subnet on port 6443. Remember, I'll be hosting the Bastion in the same subnet in which currently the Kubernetes API endpoint is hosted. Let me provide the CIDR block. Let's provide the port, which is 6443. Let's give it a description. Allow Bastion to Kubernetes API endpoint communication. Click on add ingress rules. With this, we have completed the steps required to be performed by VCN administrators. Now let's move on to the steps that the cluster administrator would perform. Let's start by creating a Bastion using OCI console and set the properties for our Bastion. Let's head back to OCI console. To create a Bastion, let me go to the hamburger menu, click on Identity and Security, and then click on Bastion Service. On the Bastion page, click on Create Bastion. In the Create Bastion dialog, let's set the properties. We'll start by setting up the Bastion name. Let me change the name to Bastion OKE. Under Configure Networking section, let's select the target virtual cloud network. Here we need to specify the VCN of the Kubernetes cluster to which we want to provide access. Let me click on the drop down here. And this is the VCN for the Kubernetes cluster OKE private Bastion demo. Let me click on it. Under target subnet, we need to provide the subnet to host the Bastion. And remember, it should be the subnet with the ingress and egress security rules that we have set up. In our case, it is the OKE K8's API endpoint subnet. Let me click on that. Let's leave this unchecked and let's go to the CIDR block allow list. Here we need to provide a CIDR range that we want to allow to connect to sessions hosted by this Bastion. In our case, we'll allow access from the internet, which means we'll set the CIDR to 0.0.0/0. Let me hit enter. And the CIDR block is added to allow access from the internet. Under show advanced options, you can optionally change the maximum amount of time that any session on this Bastion can remain active. By default, it is 180 minutes. I'll leave it as default. Let's click on Create Bastion. Well, the Bastion is now in creating state. Let's wait till it gets active. Well, our Bastion is created and is in active state. Well, we've completed the steps required by cluster administrators, basically to create a Bastion service. Now, since this video is getting a bit long, let's pause here and continue in the next part. Thank you for watching. Welcome back, and let's continue from where we left off in our previous video. Now let's move on to the steps that the cluster users would perform. We've already generated a kubeconfig file for the cluster we want to access. The next thing that we'll be doing is modifying the kubeconfig file to specify the IP and port. And as the example says, we'll have to look out for the server entry in our kubeconfig file and replace the IP with localhost IP, which is 127.0.0.1. Let's head back to our local machine. Let me clear the screen here. And let's go to our kubeconfig file, which is in the .kube directory. This is our config file. Let me open up the config file. And we need to change the IP address under the server object. Replace the Kubernetes API endpoint's private IP address with localhost, that is 127.0.0.1. Save the file and exit. Now the next step is to establish a session to the Bastion for secure access. Let's go to our Bastion service and create a Bastion session. Click on the Bastion service that we just created. Click on create session. In the create session dialog, let's set the following properties. Let's select the session type as SSH port forwarding session. Let the session name be the default session name that got generated. We can optionally change the session name. Let me change it to Bastion OKE session. Under connect to the target host section, let's select IP address and let's specify the IP address of our cluster's Kubernetes API private endpoint. In order to find the Kubernetes API private endpoint IP address, let's head back to our cluster. And from the cluster details tab, we get the Kubernetes API private endpoint IP address and the port. Let me copy the IP address. Let's go back to the Bastion service. Let's paste the IP address here. And under the port, let's paste the port number. As you can see, it's 6443. Replace 22 with 6443. Now let's specify the public SSH key of an existing SSH key pair, which we'll be using for this session. Like I mentioned, I already have an SSH key created. Let's go to my local terminal. Open up my public key. Copy the content. Paste the SSH public key here. Now again, under show advanced options, you can change the maximum session time to live for this session, which by default is 180 minutes. I will leave it as default. Click on create session. Well, the session is in creating state. It will take some time for the session to get created. All right, the session is now active. The next step is to get the command for creating an SSH tunnel to the Kubernetes API endpoint. And in order to obtain the SSH command from the session list, click on the action menu, click on copy SSH command. Let me open up a text editor and paste the command there. Let me increase the font size. Delete the comment. This is the SSH tunnel command, and we will have to replace the placeholders with respective values. For the private key, my private key is in the .ssh directory. I'll just specify the path. That's the path to my private key. And you must replace the local port placeholder with a port on your local machine which is open and free. Let me use 6443 here. And this string over here is my session OCID. Let me copy the SSH tunnel command. And let's now run the SSH tunnel command to access and operate on the cluster. Back to my local machine and paste the SSH tunnel command here. Clear the screen first. Go to our root directory. Well, this is the SSH tunnel command. Remember, we must add ampersand to the end of the command to make the command run in the background. I've added the ampersand towards the end of the command. Let me hit enter. And the tunnel is created and is running in the background. Now let's run kubectl commands to see whether we have got access of our Kubernetes cluster from the local machine via the Bastion host. There you go. From the output, it's clear that we are able to access our cluster resources. And this has fetched us the list of nodes running on our cluster. Just to cross check, let's go to our OCI console and confirm these node IP addresses. So let's go to the Kubernetes cluster and click on the node pools. Let's click on pool 1. And if you notice, our 3 nodes are running with private IP that ends with 47, 127, and 135. And let's head back to our local terminal and we can confirm that the list of nodes returned are the same nodes running within our OKE private Bastion demo Kubernetes cluster. Let me also confirm the cluster access from our local machine using Bastion by running an inline configuration to create deployment resources in our Kubernetes cluster. Create a deployment resource using kubectl. Let's use the container image nginx. and set the replica flag to 3, which means 3 pods would be created under the deployment Mahindra-Nginx. Let's hit enter. The output says deployment Mahindra-Nginx created. Let's get the status of our deployment. Well, as you can see, the deployment Mahindra-Nginx has 3 pods ready and running in it. Let us check the pod status using kubectl command. And there you go, our 3 pods that we just created as part of our deployment are in running state. Now this SSH tunnel is running in the background. If you wish to terminate the SSH tunnel, you just need to type ps command and look out for the process ID that's running your SSH tunnel and simply kill the process. Let's kill the process by running the kill command, kill space -9 and the process ID. In this case, it is 506370. Let me hit enter and the process has been killed. Now if I do a ps command, process no longer exists, it has been killed. Now if you run kubectl command, we won't be able to access our cluster. Let me clear the screen and run the kubectl get nodes command. And this will return us with an error saying that the connection to the server was refused as the SSH channel no longer exists. With this, we come to the end of this demo where we were successful in setting up a bastion to access the Kubernetes API endpoint hosted in a private subnet and run cluster operations. I hope you found this demo useful. See you in the next demo where we will be setting up a bastion to provide SSH access to our managed worker nodes. Thank you for your attention. Hello and welcome to this demo on setting up a bastion to provide SSH access to managed nodes hosted in a private subnet. Let's get started. We will start by configuring steps as performed by VCN administrator in this case. We'll start by adding the security rules, egress and ingress rules. Remember that the bastion must be hosted in the same VCN as the target cluster, and either you can create a new private subnet to host your bastion or you can leverage an existing subnet within the same VCN. In this case, we'll be hosting our bastion in the private subnet where our managed nodes reside. Now let's start by adding an egress rule to our bastion subnet. The egress rule states that we need to allow traffic from the bastion subnet to the worker node subnet on port 22. And the ingress rule specifies that we need to open up traffic on port 22 for the worker nodes hosted on our subnet. Let's head back to our OCI console. Click on Kubernetes cluster. We already have a Kubernetes cluster where our worker nodes are hosted in the private subnet. We used the same cluster for our previous demo where we showed access to our Kubernetes private API endpoint using Bastion. Click on the Kubernetes cluster. Now let's add the ingress and egress security list rules. Click on the VCN. Select the subnet where our worker nodes are hosted, as we'll be using the same subnet to host our bastion. And this is the subnet as it reads OKE-node subnet. And before that, we'll just copy the subnet CIDR block. Click on the subnet link. Click on the default security list for this subnet. Start by adding the egress rule. Let's click on add egress rule. And here under the destination CIDR, we need to provide the CIDR for our worker nodes. And I just copied it. Let me paste it here. And the destination port range is 22. Let's add the description. It says allowing bastion to worker nodes traffic. Click on add egress rule. Let's go to the ingress rules. Click on add ingress rules. Let's add an ingress security rule that allows traffic into the worker node subnets from the bastion subnet. And remember, like I mentioned, I'll be hosting the bastion in the same subnet where our worker nodes are hosted. which is why the CIDR notation for our bastion and the worker node subnet is same. Let me paste the source CIDR. Let's provide the destination port range, which is 22. Add a description. Click on add ingress rule. We have completed all the steps needed to be performed by a vCN administrator. Now let's move on to the cluster administrator steps. The first thing is to enable the bastion agent on the worker node to which we want to connect through SSH. Let's head back to our Kubernetes cluster. Let me select the pool 1. Now these are my worker nodes and I must enable bastion agent on the worker node to which I want to connect through SSH. Let me open up all three of them. Remember, these nodes run as compute VMs under our compute service. Now that I've opened them in separate tabs, let me go to the first worker node. And under the Oracle Cloud Agent tab, scroll down to find the Bastion service plugin. And let's toggle to enable this plugin. It can take up to 10 minutes for the change to take effect. Let us repeat this step for the other two worker nodes. Let's click on Oracle Cloud Agent tab, scroll down to the Bastion plugin, toggle to enable it. And this is my third worker node. Let me select the Oracle Cloud Agent tab. Let's scroll down and reach the Bastion plugin, toggle to enable this as well. Now currently the status for our Bastion plugin on all the worker nodes says stopped. We must wait until this is changed to running before continuing to our next step. So let me pause here and resume when the status changes to running. Well, after 10 minutes or so, our Bastion plugin is now in the running state. As you can notice, for our worker 3, for worker 2 also it is in running state. And for worker node 1, it says the Bastion plugin is in running state. The next step is to create a Bastion using OCI console and set the properties for the Bastion. Let's head back to the OCI console. And let's go to the Bastion service. Click on hamburger menu, click on identity and security, and click on Bastion. On the Bastion page, click on create Bastion and set the properties. Give it a name. Under the configure networking section, we'll have to provide the target VCN. The target VCN is the VCN of the Kubernetes cluster to which we are trying to access. And that in our case is VCN quick OKE private Bastion demo. Select the VCN. And the target subnet is the subnet to host the Bastion. And remember, like I mentioned earlier, that I'll be hosting the Bastion in the private subnet where our worker nodes are hosted. Select the appropriate subnet, which is OKE node subnet. Let's provide the CIDR block allow list. Basically, one or more address ranges in CIDR notation that we want to allow to connect to sessions hosted by this Bastion. In our case, I'll open it up for the internet. Let me enter 0.0.0/0. Click on create Bastion. Well, currently, the Bastion is in creating state. Let's wait till it gets active. The Bastion for managed nodes is now active. Now let's run the steps which a cluster user would run. The first step is to create a Bastion session, which establishes a session to the Bastion for secure access. Let me go back to the OCI console. Click on our Bastion. Click on create session. Now in the create session dialog, let us fill up the properties. The session type that we must select is managed SSH session. Let's provide this session a name. Let's provide a valid username configured on the target host. Remember, all our worker nodes are running on Oracle Linux, and by default, the username is OPC. Enter OPC for username. Now under compute instances from the drop-down, we must select the name of the worker node compute instance from the list of compute instances which we want to SSH into. All the active compute instances within the CTO compartment are listed over here. We need to figure out which one of these belong to the cluster that we are trying to get access to. Let's head back to our cluster to get the identification. As you can notice, our worker node names are these. They are ending with letter GSQ. Let me go back to our Bastion service, and from the drop-down list, let's select the first worker node, which is GSQ-0. Under Add SSH key section, select Paste SSH key option and specify the public key of an existing SSH key pair, which I'll be using for this session. In case you don't have an existing SSH key pair, you can always go for Generate SSH key pair option. Let me go back to my local machine. Let me go back to my local machine and copy the public SSH key. This is my public key, and let me copy the public key string. Let's head back to the console and paste the public key over here. Click on Create Session. Well, after a while, the session is now active. Now, the next step is to get the command for creating an SSH tunnel to the worker node. Let's head back to our OCI console. From the sessions list, select the session that we just created and click on the action menu. Let's click on Copy SSH command. Let me open up a text editor and paste the command there. All right, let me clear the comment. Well, we need to replace all the placeholders. Basically, there are two placeholders in this command where I'll have to replace it with the path to my private key. Let me quickly replace it. I have replaced private key placeholder with an absolute path to my private key on my local machine. Copy this command. Let's head back to my local machine. Clear the screen. Go to my home directory. And let's run the command. Well, the moment I hit enter, this command will help me get an SSH access of my worker node with the IP 10.0.10.47. Let me go ahead and hit enter. Well, on this prompt, let's simply write yes and hit enter. All right, as you can notice, the prompt has changed. Now I'm no longer in my local machine. I've got an SSH access of my worker node. In order to exit out of an SSH session, simply write exit, and this will take you back to your local terminal. Now, in order to connect with other worker nodes in your Kubernetes cluster, you simply have to create similar sessions. You have to click on Create Session, fill up all the required properties, and remember to select the right worker node from the list of compute instance. And provide the public SSH key and click on Create Session. This will help you create another session to your different worker node. Let me click on Cancel. Now you can perform operations on the worker nodes until the SSH tunnel or Bastion session times out. With this, we come to the end of this demo where we successfully set up a Bastion to provide SSH access to our managed worker nodes hosted in a private subnet. I hope you found this demo useful. See you in the next one. Thank you so much for watching. Welcome to this module on working with OKE virtual nodes. In this module, we'll dive into the concept of OKE virtual nodes, offering you a complete serverless Kubernetes experience. We'll kick off by comparing virtual nodes with managed nodes, offering insights into their differences and advantages. You will gain insights into the prerequisites for configuring clusters with virtual nodes and learn about virtual node and node pool management, including resource allocation strategies. These concepts will be reinforced with hands-on demonstrations to enhance your understanding. Let's uncover the serverless offering and unlock its potential for your Kubernetes environment. Let's get started. Hello and welcome to this lesson on comparing virtual nodes with managed nodes. I am Mahendra Mehra and I am a senior training lead and evangelist with Oracle University. When creating a node pool with Container Engine for Kubernetes, you have the option to specify the type of worker nodes as either managed nodes or virtual nodes. However, it is important to note that there are some key differences in the features supported by each type. Let's dive into those differences and explore each approach. The primary point of differentiation between virtual nodes and managed nodes is in their management approach. When it comes to managed nodes, users are responsible for managing the nodes. They have the flexibility to configure them to meet the specific requirements. Users are also responsible for upgrading Kubernetes on managed nodes and for managing cluster capacity. You can create managed nodes and node pools in both basic clusters and enhanced clusters. Whereas in virtual nodes provide a serverless Kubernetes experience, enabling users to run containerized applications at scale. The Kubernetes software is upgraded and security patches are applied while respecting applications availability requirements. Also make a note, you can only create virtual nodes and virtual node pools in enhanced clusters. Another key point of differentiation is in their approach to resource allocation. When it comes to managed nodes, the resource allocation is at the node pool level, and the users specify CPU and memory resource requirements for a given node pool. In the virtual nodes, the resource allocation is done at the pod level, where you can specify the CPU and memory resource requirements, but this time as requests and limits in the pod specification. A third point of differentiation between virtual nodes and managed nodes is in their approach to load balancing. When it comes to managed nodes, load balancing is between the worker nodes, whereas in virtual nodes, load balancing is between pods. Also, load balancer security list management is never enabled, and you always must manually configure security rules. When using virtual nodes, load balancers distribute traffic among pods' IP addresses and then assign node port. As you can see, the syntax says pod IP:node port rather than node IP:node port. The next point of differentiation is pod networking. Under managed nodes, both the VCN native pod networking CNI plugin and the Flannel CNI plugin are supported. When it comes to virtual nodes, only VCN native pod networking is supported. Also, only one VNIC is attached to each virtual node. Remember, IP addresses are not pre-allocated before pods are created, and the VCN native pod networking CNI plugin is not shown as running in the kube system namespace. Pod subnet route tables must have route rules defined for a NAT gateway and a service gateway. Next up is scaling Kubernetes clusters and node pools. So when it comes to managed nodes, customers have the responsibility for adjusting cluster capacity in response to the changing requirements. They can scale the cluster and node pool up and down by changing the number of managed node pools and nodes respectively. They also have an option to enable auto-scaling to automatically scale managed node pools and pods. When it comes to virtual nodes, operational overhead of cluster capacity management is handled for you by OCI. A virtual node pool scales automatically and can support up to 1000 pods per virtual node. Users also have an option to increase the number of virtual node pools or virtual nodes to scale up the cluster or node pool respectively. Let's talk about pricing. Under managed nodes, you pay for the compute instances that execute applications, whereas under virtual nodes, you pay for the exact compute resources consumed by each Kubernetes pod. So to wrap up, when it comes to choosing between virtual nodes and managed nodes for your Kubernetes cluster, there are several key points of differentiation to consider, including management approach, resource allocation, load balancing, pod networking, scaling, and pricing. By understanding the benefits and drawbacks of each approach, you can make an informed decision that meets the need of your specific application and workloads. I hope you found this lesson useful. See you in the next one. Thank you for watching. Hello and welcome to this lesson on prerequisites to configure cluster with virtual nodes. I am Mahendra Mehra, your senior OCI instructor at Oracle University. So let's get started. Let's discuss the required IAM policies for using virtual nodes. And these policies are crucial for both tenancy administrators and non-administrator users. Let's jump into the specifics. Before you can use virtual nodes, you always have to set up at least one IAM policy, which is required in all circumstances by both tenancy administrators and non-administrator users. This basically means to create and use clusters with virtual nodes and virtual node pools, you must endorse Container Engine for Kubernetes Service to allow virtual nodes to create container instances in the Container Engine for Kubernetes Service tenancy with a VNIC connected to a subnet of a VCN in your tenancy. So all that you need to do is create a policy in the root compartment with the following policy statements exactly as shown on the screen. You can copy and paste these policies from the official documentation page, and you will find them under the Working with Virtual Nodes section within the Container Engine topic. So you just need to copy these as it is and paste it in the root compartment of your tenancy. Now let's move on where we'll continue discussing the necessary IAM policies for using virtual nodes. Pay close attention, especially if you are a non-administrator user looking to utilize virtual nodes. For a non-administrator user, these are the policies that must be in place for them to actually work with virtual nodes in a Kubernetes cluster. These policies allow the non-administrator users to manage cluster virtual node pools, to read virtual network family, and to manage VNICs in compartment. The same is also available in the official documentation. You can simply copy paste these policies from the official documentation page. Let's head back to our slide. We are going to explore the creation, configuration, and network setup of virtual nodes and virtual node pools. Let's start by focusing on the creation process. Creating virtual nodes is a pivotal step and it involves setting up a virtual node pool in a new cluster. And this is exclusively applicable to enhanced clusters. You can initiate this process using the console, the CLI, or the API. Now let's shift our focus to the configuration aspect. Configuring your virtual node pools involves defining critical parameters. Firstly, we have the node count. This represents the number of virtual nodes you wish to create within your virtual node pool. These nodes will be strategically placed in the availability domains that you specify. Now, it's important to carefully consider the placement of these nodes. You can distribute them across different availability domains, ensuring high availability for your applications. Additionally, you have the option to place these nodes in a regional subnet, which is the recommended approach for optimal performance. Moving on to pod shape. This refers to the type of shape you want for pods running on your virtual nodes within the virtual node pool. The pod shape is